Question 2, we've got bins of size 20. Let's write that down so we remember as we go. And we're going to put them, first of all, the 5 comes along, so it goes in the first bin. The second, then a 1 comes along. What do we got? That's up to 6. The 8 fits in there as well. But then the 13 won't fit in that one, so we'll have to start a new bin. The 16 is not going to fit in any of those, so we'll have to start a new bin. The 5. Now the 5 actually fits back in that first one there. So we've only got 1 spare for that one now then. The 8, would the 8 fit in there? No, that's too much. Would the 8 fit in there? No, that's too much. So we'll start its own bin. The 2 doesn't quite fit in there, but would fit in that one. 15's clearly going to need a new bin of its own, isn't it? So we'll start a new bin with the 15. The 12, no. Oh, it will fit in there. And the 10, no, yeah. So first fit decreasing, first fit algorithm, it would be bins like that. But now we've got to do them in decreasing order. This is the hardest bit. I'm going to pause while I do this. Okay, so I've just written them in order, and this time the 16 goes in the first one, the 15 goes in the second, the 13 goes in the third, the 12 goes in the fourth, the 10 goes in the fifth, but we then have an 8. So the 8 can go in with that one there. Actually, I should have put it in that one there first. Luckily, there were 2 8s. That one's going in there, that one's going in there. This 5, let's get that right, goes in that bin there. That 5 goes in that bin there. And then we've got the 2 and the 1, which go in there. So we actually managed to fit it in 5 bins rather than 6, like we had earlier. Now, I would have said that's the best it could possibly be, but we could prove that just by adding them all up. The grand total of all of this is 95. And each bin's having 20, so 95 divided by 20 is 4.75. So you know the minimum number that you're going to use is 5. That's the lowest number of bins you can do, and we've just done it. So it's an optimal solution.